TXRX Systems tower site equipment is used in land mobile radio to enhance the receive characteristics of base station and repeater sites, and to give portables, mobiles, and handhelds better range and capabilities. Several types of equipment, including combiners, receive multicouplers, and TTA systems, have been covered in other sections. This presentation will give an overview of TXRX field services. TXRX has a long history with RF site equipment and offers some of the most advanced and reliable components available, and through that experience has become a leader in site services. While this section will cover basics of site monitoring and troubleshooting, interference mitigation, and training, the technician should always hone his or her skills, keeping up with technology, becoming more valuable. More information will be included in later sections. A table of contents is included to assist you in finding what you need. This section is an introduction to field services at TXRX and will include the topics listed. TXRX Systems began producing equipment for land mobile radio sites in 1976, based on a knowledge of first responder communications. Life-critical radio involves hardware, but more importantly, hardware that is free of noise and interference, making communications solid, understandable, and usable in all critical applications. The Field Services Division helps in two areas: in troubleshooting and monitoring communication systems, and in training technicians and engineers in the design and optimization of LMR systems. The TXRX Field Services Division is composed of a group of engineers and technicians with decades of field and lab experience in assisting with problems in LMR systems and in making recommendations to solve those problems. The approach is short-term and long-term monitoring, reporting findings, and presenting solutions in both low-level or noise-related problems and in high-level or interference-type problems. With over 40 years of experience in RF system design in a highly specialized field, TXRX does not find engineers needed, but instead builds them. Taking that knowledge and training to the field is a natural extension of what TXRX does. Offering classes in areas such as combiner design and optimization, receive system enhancement, interference mitigation, and other topics is part of the TXRX daily activities. TXRX provides different types of site monitoring services depending on the problems encountered at sites. All types can be achieved remotely or with a technician on site based on the analysis needed. Advanced Spectrum Logging, or ASL, is a procedure developed by TXRX Systems. An ASL kit is used for constant monitoring of specific channels over a longer time period. The kit is packed in a rugged container and includes a laptop loaded with the ASL software, driving a spectrum analyzer, and records all the analyzer traces on the computer hard drive. Once recorded, the traces can be played back using any normal spectrum analyzer display function, including max hold, min hold, markers, or waterfall. With an internet connection, the ASL kit can be accessed remotely at any time for real-time monitoring, playback of an event, or for starting or stopping the recording. By adding a GPS receiver to the ASL kit, signal levels and location can be recorded on several different frequencies for remote interference investigation. Spectrum analysis and monitoring, or SAM, is very similar to advanced spectrum logging, except that it is designed as a pre-sale or pre-designed service. Data is collected covering channel usage and high-level carriers. The SAM process looks at the spectrum activity from approximately -80 dBm up to the maximum levels observed while data is collected for 24 hours. The reporting is far more extensive than the ASL report, with detailed information and commentary. Noise analysis and monitoring, or NAM, is primarily a pre-sale or pre-designed service. It utilizes a computer-controlled crystal filter in addition to the basic SAM equipment. This process is designed to measure on-channel energy from -80 dBm down to near KTB, the thermal noise floor. Extensive reporting is provided that the engineer can utilize to refine coverage predictions based on the environmental noise at the site. Our equipment and people are very flexible and always open to new ways of resolving your problems. Custom monitoring solutions and reports are available. The ASL kit consists of a computer-controlled spectrum analyzer and a laptop computer housed in a rugged carrying case. The entire kit is about 30 pounds and can fit in an airline overhead luggage compartment. The kit can be either battery or AC operated and can also be used in a vehicle with a cigarette lighter adapter. All spectrum analyzers need some type of external filter to prevent overloading, and these filters, along with an antenna, can be provided by the TXRX team if needed. The unit can also be connected to a site multicoupler or antenna for an exact capture of system spectrum. By utilizing the ASL kit with remote access, along with the assistance of TXRX engineers, interference problems can often be diagnosed and a plan developed to resolve problems without the time and expense of an on-site investigation. The TXRX team has been very successful in solving customer problems using this process. By adding a GPS receiver to the ASL kit, signal levels and location on several different frequencies can be recorded. The data can then be processed into maps that display signal levels, or signal-to-noise information and location. This can be very useful in determining the cause of subscriber or talk-out coverage issues. The basis of all RF investigation is that results get reported. ASL reports show amplitude versus frequency information, which is very similar to a spectrum analyzer run in the max hold mode. The report will also contain amplitude versus time data that are called frequency reports. These reports show the activity on a specific channel for up to 24 hours. The ASL kit is programmed using customer-supplied information and shipped to the site. The kit contains an active cellular air card for remote connectivity and the software needed to drive spectrum analysis and report processing. Once the data is collected on up to 100 frequencies, a basic spectrum report is provided without in-depth analysis or commentary. The data can be delivered quickly, usually on the same day as collected. Locations without cellular service or internet connection, including operations outside the United States, will require the customer to provide the necessary internet connection or to copy and separately upload or send the data to TXRX Field Services for analysis. TXRX Systems has decades of experience in designing and building transmit and receive systems for LMR sites. So as a natural extension of those skills, TXRX offers site validation services as part of their catalog of field service activities. Included in the services are transmit combiner evaluation, receive system selectivity assessment, the measurement of receive system gain and sensitivity, and antenna isolation evaluation. Each of these skills aids in the improvement of receive site sensitivity, and the evaluation of transmit combiners may identify problems to other systems or to your own system. Antenna isolation is an assessment of antenna gain and pattern versus the distance on the tower separating transmit and receive antennas. The knowledge available through TXRX Field Services team will save system engineers and technicians hours of time looking for problems or interference. In some situations, you may be your own worst enemy, as your transmitters are usually the strongest signal coming into your receivers. In order to identify an external interferer, it is first necessary to eliminate internal sources, a difficult and time-consuming activity. TXRX Field Services uses all available information and experience in interference mitigation efforts. Interference hunting, as it is commonly known, requires meticulous attention to detail and all the accumulated experience an engineer can bring to bear on a situation in order to successfully resolve problems. Interference may be caused by unlicensed or unknown sources, but sometimes problems are found to be within a system. Advanced spectrum analysis kits are often used as the first line of defense against interference. ASL kits are set up and allowed to collect spectrum data for extended periods of time, possibly capturing the interfering signal in the process. If the interfering signal continues after the use of the ASL kit, other steps will be utilized, including planning for a TXRX engineer to visit the site or system. Correlating site or channel activity to the FCC database will show whether the problem is caused by a licensed or unlicensed transmitter. On-site signal data and using directional antennas will bring the engineer closer to the source of the interference. Putting all the information gathered together with customer information can be difficult, but the result will be a much more usable system. The spectrum display shown here was found to be degradation caused by tower lighting at the site. The problem was investigated following a storm, and with only the early morning light, the sky was very dark and the tower marker lights were on. As the sky grew brighter, the interference stopped, a clue that the problem was related to the lights. The tower lights were switched into night mode, which turned them back on, and the interference returned. When in day mode, there was no interference. The conclusion was that the problem was caused by electrical noise caused by wet tower lights when in night mode. Correlation of data is vital in interference mitigation work. By adding GPS to the ASL kit, the signal levels can be recorded along with the latitude and longitude of the location where the measurement was taken. The ASL kit with the required mobile antenna, filter, and GPS can easily be set up in a vehicle for mobile use. Several frequencies can be monitored at the same time as the vehicle is driven through the area to be investigated. After the data is collected, it is uploaded to TXRX, and a map will be generated showing the signal levels, the noise levels, or the signal-to-noise ratio along the route taken. This will allow the engineer to determine if poor system performance in each area is due to low signal strength, localized high noise, or a poor signal-to-noise ratio. For the traces shown, all signals and noise measurements were logged along with the time and GPS locations. Information was then plotted onto several maps. The maps shown here include a signal level map near the top, with only one area showing signal levels below an acceptable threshold. The second plot is a map of measured noise levels, showing various levels of noise indicated by the color of the location dots. The final map is a combination of the first two maps, displaying the signal-to-noise ratio. For this project, the areas of poor communication did not have weak signals, high noise, or a poor signal-to-noise ratio. Based on this information, the problem was identified as multipath interference. The TXRX System Field Services Group has developed a system for remote interference investigation through real-time monitoring of the site and spectrum recording and playback. Using local technicians and remote TXRX engineering experience, along with an ASL kit and remote connectivity, signal levels can be recorded at multiple locations for an extended period, identifying interference events as they happen. Correlation of events is a requirement of interference mitigation. Customer reports of interference or degraded communications can be compared to events displayed on the spectrum analyzer screen at that time for the problem to be evaluated, identified, and solved. Since the spectrum is being recorded, events can be played back in time, allowing the technician to view past events. By seeing the events, it is possible to determine if the interfering signal was co-channel or adjacent channel or even wideband noise source. Any number of frequencies can be monitored. If the situation cannot be solved remotely, a technician is sent to the site with the advantage of having more information on the nature of the problem. Some LMR sites are so remote and so treacherous that remote monitoring may be the only option available. In these instances, technicians from both the customer and TXRX must work together as a team, closely cooperating, collecting all the data needed. At some sites, a real-time data feed is not possible, and return to mountaintop sites in winter is more than challenging. But due to the experience TXRX has accumulated over decades of interference mitigation, some solutions just require a bit more creativity. Various tools are used in the process, including spectrum analyzers, receivers, directional antennas, and Doppler direction finding equipment. Again, the steps are identify, isolate, locate. Sometimes these steps can be difficult, but with a focused, meticulous approach, the problems will be solved and a final report issued at the conclusion of the investigation. Interference mitigation requires experience, knowledge, and discipline. An engineer tasked with mitigation needs to ignore preconceived ideas about what the source of the problems are and focus on resources on finding the actual cause. The final steps in interference mitigation may require diplomacy and the use of regulation enforcement to bring about resolution. Finding out after installation that your system doesn't work well is not a good situation. The equipment has been purchased, the tower is up, the equipment is installed, and the noise level is so high that coverage is terrible. Site monitoring before moving blindly ahead would have made much more sense. TXRX was founded on the knowledge of how sites work and how to build site equipment for LMR systems. The TXRX Field Services Division takes that knowledge and puts it together, giving engineers the level of information required for today's systems. Site monitoring is performed before the infrastructure is installed, with the process optimized to provide the most detailed information possible. Depending on the site, monitoring equipment can be placed at the proposed location in an existing shelter, or by using a completely self-contained trailer with a generator or battery power. Site monitoring is available at two levels, spectrum analysis and noise analysis, SAM and NAM. The two services are optimized for different signal levels. Spectrum analysis and monitoring, SAM, records high-level signals using software that drives the spectrum analyzer for a much longer time period, watching for anything that happens from 24 hours to 2 days to 2 weeks. Spectrum analysis identifies which frequencies should not be used and also which frequencies can be used in the system. Analysis of high-level signals ahead of the system design will allow proper receive filter design, saving delays, and possibly extensive redesign work. Noise analysis and monitoring, or NAM, records low-level signals when compared to a spectrum analyzer which covers high-power signal levels. To measure noise, maximum sensitivity is needed, so the kits are optimized to receive very low signal levels. Noise can be just as destructive as high-level signals since it causes system receive degradation, which results in loss of coverage. Noise analysis predicts how much noise will occur on the system receive infrastructure. Spectrum analysis has always been a time-consuming process involving a technician or engineer sitting in front of a spectrum analyzer waiting for something to happen. If the technician was in the right place at the right time and knew what he or she was looking for, they might be able to figure out what was causing system problems. Maybe. More often, the time waiting was the wrong time, or the problem was there and gone before it was seen. It was never recorded for further analysis. TXRX spectrum analysis allows long-term monitoring to capture that interferer Friday afternoon during rush hour traffic. Site monitoring services from TXRX provides many levels of noise and signal monitoring. It is hard to predict what kind of interference you're receiving, noise or high-level carriers. Spectrum analysis and monitoring help in figuring it out. Many different things contribute to system degradation, from power line noise to high activity on a system. Thermal noise and cosmic or atmospheric noise will result in loss of sensitivity. Channel usage by systems nearby can be totally destructive, so a check of actual usage versus the FCC database is useful many times. The picture shown is an industrial complex that was suffering from interference and noise from an unknown source. The field service investigation conducted by TXRX, both remotely and on-site, showed the noise source to be the power transformer in the lower left picture. The trace capture shows the noise being received at the monitoring site, which caused severe system degradation. The Spectrum Analysis and Monitoring Report, or SAM, provides comprehensive data on the RF spectrum at the site. Several different report formats are provided. A spectrum activity report is an amplitude versus frequency format similar to a spectrum analyzer display allowed to run in max hold mode, showing all of the activity across the monitored spectrum. High-level carriers are identified, and information is provided on their frequency, amplitude, and number of occurrences. In addition, FCC data for any license located near the site is also included when available. Licensing data for systems outside the United States will not be included. Channel activity reports show all the channels identified by the customer. These reports are in amplitude versus time format, displaying activity for each individual channel for the duration of the monitoring, normally 24 hours. An inactive channel report is a comprehensive list of all frequencies with no activity and is included with the report as potential channels for the system. TXRX Systems Noise Analysis and Monitoring Report, NAM, provides comprehensive data on RF noise environment at your site. Several different report formats are provided. A channel noise report or chart is provided that displays the site noise in external noise relative to KTB, the thermal noise floor, the median and minimum noise, the projected effective receiver sensitivity or ERS, and the degradation based on typical receiver sensitivity. A noise frequency report displays the external site noise in an amplitude versus time format, so the engineer can see how the noise changed over the monitoring period, normally 24 hours. This graph also displays projected ERS. Since the inception of TXRX Systems, the sharing of radio frequency technical information through white papers, seminars, presentations, and operational manuals has been and became standard procedure. In 2003, an effort was begun to formalize the training of technicians and engineers in many topics within the RF industry. Most of the training materials were directly related to equipment manufactured by TXRX and sister companies and included a hands-on approach to training. Most technicians and engineers learn more by doing rather than by listening to lectures. The training was designed to be classroom-based, instructor-led, but technician-focused, and continues to be just that. Many of the first classes are still taught, but due to changes in ownership within TXRX, some are not offered as often. Topics range from beginner-level material through site and system design and interference mitigation. All of the classes are strong in theory and application, with all carrying a manufacturer's certification through TXRX, and some carry an Electronic Technicians Association certification as well. Classes are presented as web-based learning and in classroom settings as needed and are between 15 minutes and 4 days in length. All classes include lab time and testing for certification. You will also find classes offered through the IWCE at the annual convention and as engineering seminars. Some of the TXRX Systems classes have been contracted by major radio manufacturers in both production of the schools and in delivery of the material. The topics listed cover land mobile radio, and while focusing on infrastructure equipment, still include a great deal of information about transmitters and receivers, as well as other site equipment. As noted, many of the topics included in the list of classes are directly related to equipment produced by the company, but the application in theory applies to all equipment in the LMR communications industry. In several of the classes, such as RF network analysis and antenna system analysis, students build an LMR or cellular site using equipment external to both transmitters and receivers, and then test their efforts. Signal investigation techniques involves a signal hunt, where students are required to find an interferer using a Yagi antenna and a handheld spectrum analyzer. All students are involved and get an opportunity to learn new skills and techniques. Thank you for being part of this training module, for inquiring about TXRX systems and services, and for being part of our technical community. This section was intended as an introduction to TXRX field services and what they offer to land mobile radio systems. More training modules are available in support of this and other topics specific to products manufactured by TXRX Systems. The material is available in short versions and in longer half-day, full-day, and 2-day classes, with some covering 4 days. Visit our website at txrx.com for more information. Titles and topics are being added weekly, so please come back often to see what is available. Classes are available at TXRX Systems 8625 Industrial Parkway, Angola, New York, or if your group or shop is large enough, we will bring the training to you. Please call 716-549-4700 to discuss fees and scheduling. Again, thank you for being part of this presentation, and we do invite you back.